The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. We have quite the episode in store for you today.
So this week, we're going to talk to Terry and Dan, who found a unique piece of video game history.
Okay, so you know how they had a lot of CD-ROM add-ons for video game consoles in the early 90s?
Yes.
The Sega Genesis had one, the PC Engine had one, even the Atari Jaguar had one.
Yeah.
The Super Nintendo was going to have one, and it was going to be made by Sony, but it never came to pass.
Like the makers of the PlayStation?
Yes.
Okay.
So the PlayStation originally started as a joint venture between Nintendo and Sony. The PlayStation was going to be the CD-ROM add-on for the Super Nintendo.
Oh.
So it was one of those things that, you know, it's kind of a rumor, like, okay, this is part of history, but no one's ever actually seen any proof. But it turns out Terry and Dan found proof. They found a prototype combination Super Nintendo CD-ROM add-on labeled the Sony PlayStation.
But with a Nintendo cartridge slot.
Yes. So yeah, it's, you know, it's like one of those things, it's like finding the missing link,
Yeah.
really. So they're gonna bring it on the show, but first they're gonna tell us the story of how they found it.
I used to work for a company named Havana Corporation, and when they went and filed for bankruptcy, what you would do is you go around to the buildings, you take pictures, you create itemized lists, plates, cups, saucers, you know, that's basically what I was packing up. So a lot of the stuff was still new, and that's one of the things I wanted to bid on. I mean, 2 conference rooms, it was a lot of plates and stuff like that. And it started out at 25, it went 50, it went to 60, and I said 75, and it stopped. And so I won the auction. People probably didn't read the bottom line saying how many boxes there were, but I knew how many there were since I packed them all.
So one day, my dad came home from work with a box of what I thought was junk. We started going through it. There's just a bunch of CDs and stuff in it. And then we saw the Nintendo PlayStation sitting in the box. We weren't quite sure what it was at first. We tried looking up some stuff online, couldn't really find much information. So we knew it was pretty rare. We kind of just put it in the attic for a while. I saw a post on Reddit talking about the Sony and Nintendo collaboration, or how they once worked together. So I just commented on there. I just left a little comment that said, yeah, my dad's got one of those in his attic. Of course, everybody started freaking out. Like, do you have Half-Life 3 too? And I'm like, no.
And if you break it down for everything that I did buy, and the lot number per plate, per cup, for spoons and fork, I probably ain't paid a nickel for it, you know, if that. I mean, you know, because between the hundreds of music CDs and everything else, I would have to actually sit down and itemize on how much items I actually bought, and then broke it down into $75 to see how the ridiculous price I paid for it.
Right now, we can't get a video signal to the screen, there's no sound, and the disk drive isn't receiving power. We had video signal before when we've tested it in Hong Kong. We played multiple games on it, but we've never had sound or power to the drive. So we're hoping Ben Heck can fix that for us. Everybody says if anybody can do it, it's Ben.
That was a pretty interesting story.
Yeah, it's good to know there are still some mysteries left to discover in this world. So this is going to be a 2-part episode. In part 1, we're going to tear down the unit very carefully and see what's inside. We want to analyze all the integrated circuits and parts to figure out what the system would have been. How would it have compared to contemporary CD-ROM add-on systems in the early 90s?
And in part 2?
Well, the system at the moment doesn't actually work, so we're also going to try to fix it. So once we've analyzed everything, in the second episode, we're going to see what's wrong, use the multimeter, use the scope, get it working again, and then hopefully play some Nintendo games on it, Super Nintendo games, and also maybe get the CD-ROM to spin up, because right now the CD-ROM doesn't do anything.
Okay.
We'll try to get a music CD playing. We don't have any disk software, but we'll try to fix as much as we can. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, well here it is, the fabled Sony Nintendo PlayStation prototype. So before we crack this open, which we're definitely going to do, let's take a look at it. Well, there's really no Nintendo marking on it at all. It's mostly Sony. So remember, the story was that it was originally going to be an add-on for the Super Nintendo. So you have a Super Nintendo here. See how there's an expansion port on the bottom? That's where it was going to plug in, just like the Sega CD that plugged into the Genesis. This is interesting. So you know how old plastics become yellow? And it's not just people who smoked, the sunlight also does it. But look at this right here. There's almost like a shadow. So it looks like a controller was left plugged in. Actually, here's the controller that goes with it, also yellowed. So yeah, this must have been like on someone's desk or near a window. So the sun came down and this was in place, shading part of the plastic. That is so bizarre. It's also kind of weird that only that piece of plastic was affected. But if you look at the bottom here, this mating is not so great. So this was possibly assembled from a couple different prototypes. You know, maybe it was a different batch because, you know, not all old electronics yellowed like this, just some of them. So that may be why the rest of it's not really affected, which is good because most of it is a nice color. So this is pretty cool. The power switch, when you push it in, the eject button is mechanically arrested. That's pretty neat. That is a lot better than that lever that you were supposed to use on the Super Nintendo that no one ever did. Okay, so this is pretty common back in the day. You know, if you had like not the original Sega CD, but like the second Sega CD, you know, you have control buttons on it. So this is your standard CD-ROM stuff. People might think of like Sony and Nintendo as bitter rivals, which I guess maybe they are now, but back in the day, they weren't. I mean, there are chips on the Super Nintendo labeled Nintendo and Sony, the audio processors. Heck, you can open up an Apple IIgs and there are chips in that labeled Microsoft and Apple. So, you know, these companies don't necessarily hate each other. You know, they work together because you remember Sony was a big audio manufacturer back in the day. You know, they made Walkmans, they made the first Discman, obviously. So if you want a really good CD player, you went to Sony. Although that's not ultimately what Nintendo did, but that's another story. So let's look at the back here. So this is interesting. This is the same sort of multi-RF out that you would see on an early 90s Sony camcorder. I know because I had one. So what you did was you had this little box that plugged in right here. And this was the power. So this was a powered RF modulator, and this would hook up to your TV. Oh, S-Video, that's nice. And this is your standard Super Nintendo multi-out, so you could probably get RGB out of this. And this next, probably some sort of serial debugger, if I had to guess. The early PlayStations had it as well. But yeah, it's in really good shape. And this is interesting. Recognize that? I wonder why they have that. I mean, you know, a CD was meant to plug into your Super Nintendo. So what were they going to plug into this? Maybe a disk system? Again, like in Japan, there was a 3.5-inch floppy disk drive attachment for the original Famicom. So who knows what they were planning. There was also a disk drive add-on for the Nintendo 64. It's remarkably finished looking, honestly, for a prototype. I mean, you know, Sony would have made an entire tooling for this, which is not an inexpensive amount of money. Of course, they're Sony. They were pretty big back then. I mean, they're still big, but honestly, they were a bigger company back then. Oh, and you can tell that it was manufactured by Sony because they have their Sony disassembly arrows here, pointing to the screws as if you couldn't see them. Thanks, Sony. The outside of this unit is all well and good, but in the words of your guidance counselor and every Disney movie, it's what's inside that counts. Okay, so Dan is here. He's going to guide me through the disassembly because he's taken it apart before. So yeah, just tell me if I'm doing anything wrong.
Will do.
All right, so we start with the 4 or 3 screws on the back?
Yes, sir.
All right, here we go. Well, this doesn't have those infernal Nintendo security screws.
I think
so take it off upside down like this?
Yeah, you should be able to just pop the bottom off now.
All right, before.
And then you take the screws off on the inside, there's a couple more, and then the top should come right off.
I'm just curious. Oh, okay, yeah. So if you take a look at this, see that's supposed to mate like that? Mm-hmm. I'm thinking like there's probably more likely that there's something wrong with this part. See how it kind of bends out a little bit? Okay. Yeah, this is like Indiana Jones. It's like opening up a tomb. And this will release the top lid.
Yeah, and you should be able to just flip it over and take the top off. Now, like I said, you want to pull the back up first.
It's popped off before.
Yeah.
Oh, there we go.
Yeah. See how it just slides right up.
Oh,
yep,
yeah.
There it goes.
Right. This is quite the mechanism. Look at that. That would not have been cheap. Let's take a look at what we have thus far. So we have pretty much a self-contained CD-ROM drive. It's going to be slide out because it's got the magnetic disc. This thing will click in once the drive engages. So there's going to be a drive mechanism that lifts up, engages the disc with this magnet, and then holds it in place. So this is probably going to be some sort of motor driver or CD-ROM controller. Okay, this one says NEC, so that's a good match because it's an NEC part. 4-bit single-chip microcomputer. Really? Oh, okay, yeah, this is going to be status indicator lights, Yeah, so you got a couple of transistors there that are turning the lights on from probably the GPIO on this microcontroller. So this is basically its own little processor.
Okay, cool.
Probably getting commands from the program saying, hey, seek this particular sector or go here. And then this thing would do that independent of the Super Nintendo. There has to be like a good amount of RAM on here, because what you would do is you would load something off the disk, put it into RAM, and then the Super Nintendo could execute it.
Okay.
That RAM could also be in the cartridge though. So I'm going to try to remove the CD-ROM drive now. You know, it's funny, like we're taking this apart before we turn it on. Don't turn it on, take it apart. I do that a lot with things. I'm like, well, I assume this works. Oh, wait, what's this in the back?
Oh yeah, there's another ribbon cable. It's attached underneath
To the motherboard?
Yeah.
Wow, that's a lot of ribbon cable.
Yeah.
Okay, so this microcontroller is probably just running the display. Yeah, see, it's directly hooked up to that.
Yeah.
So this is actually what's controlling your drive. And there's a bodge right there, capacitor across it. So this is going to be your motor driver here. This is your control chip. That's probably some kind of buffer. The power switch reminds me of the Super Nintendo. It's actually mounted pretty much the same way. All right, let's go here, here. So from the back, you say?
Yep. Flip it over, and then
Remove the RF shield.
yeah.
Got it. Okay, here is the good stuff. Oh my God, these bodges are not good.
No?
Oh, well, look at this for instance. They have a surface mount chip. They pulled up and tombstoned, and then they didn't want it attached where it was, and they had to put it over here. So, okay, now it's looking more like a prototype. So on this work RAM, according to the Super Nintendo data sheet, the pin they pulled up is the syscheck pin, which in the schematic goes to the CPU and looks like someplace else. It also goes to what? Well, here they've bodged it over to the CPU and the cartridge slot. So let's just take a look and see if we can find, oh yeah, here we go. Well, that goes to a bunch of things. It goes to the Sony sound chip, and does it go to the cartridge slot though? Yep, see, syscheck on the cartridge slot. Yeah, and then this, it looks like just a standard, logic circuit. There's a 7.4 at the beginning, which would make it a 7400 series logic circuit. I wonder if these are the two sound chips. So again, on the Super Nintendo, there was a Sony SPC 700 sub CPU. I don't see that number there. This part is running the CD-ROM, so that's not really as important. We're mostly looking for what matches the Super Nintendo.
Yeah.
These might be improved versions of the chip that's in there. Maybe they can handle more RAM. I don't know. I mean, the thing is, if no one else has been inside this, no one's probably documented it, you know? Like whenever you find this stuff online, it's because someone documented it for the first time. Okay, I'm gonna remove the PCB. Oh, now we can see everything. SFX. That could be Super Famicom X. Could be what they were going to call it. Yeah, okay, so there's not much here, but there are 1, 2, 3, 4 RAM chips here. There's 256 on them, which means they're 32K each. So these are probably, again, the 64K for audio, 64K for video. But I'm still going to look them up. Okay, yep, so that's a 32K 8-bit static RAM. Well, here's where they're mixing the two audio channels. Oh, there's your main power regulator. That is 7805. Pretty common, that means everything runs off 5 volts. Let's see what that's closest to. Okay, so that's closest to these. So my guess is that these two chips do the same thing as the two Sony chips in the Nintendo. So you got a DSP and an audio processor. And we can double check the connections, but that's, I mean, if you see their orientation, they're below these, which means that's what they're probably connected to. I mean, most certainly. See these vias here? Vias are when traces go through the circuit board. Via, it's Latin for the way. So it goes through, and you look over here, boom, they go right to that RAM chip. So these are gonna be your audio RAM chips. Then, by process of elimination, we can assume that these are the video RAM. And what brand are they using over here? Okay, so they did switch manufacturers, but it says a vintage chip. Yeah, okay, it's a 32K 8-bit RAM. Yeah, all right, let's see what else we got here. Another Sony chip, what a shock. Oh, looks like more RAM. See that hyphen and then the number like hyphen 70L, 12T, that's the speed of it. You know what, that's probably like a buffer for the CD of some kind. All right, we're looking at the systems and comparing them. There are a lot of similarities. So you've got CPU, 2 picture processing units, and work RAM. And which means, see these 2 RAMs here? Those are the video RAM. So you're probably gonna have 2 video RAMs somewhere. It might be that. We can look up the part number. Obviously these 4 chips match. So on the Super Nintendo here, because remember how we talked about how there were Sony parts in it?
Yeah.
There is a digital signal processor and then also another audio chip. So with this, I think you had 64K of audio memory as well. And these are probably gonna be the audio RAM. So we're probably gonna try to find equivalents on here. There is, I'm not sure what that's gonna be. I mean, these are really obvious. I mean, yeah, look at how closely they're laid out. This is the cartridge that came with the system. It has a sticker on it, 1992-10-6, and underneath there's another sticker which looks like 92-921. So they're probably making revisions of the ROM.
Apparently, the Japanese roughly translates to like for demo use. So
Interesting.
that's what we've been told.
Wonder when the system was supposed to come out. Got a big battery. I wonder if it has voltage still. Let's take a look. Yeah, this has 3.1 volts still. Well, the most obvious thing that I see here is a socketed ROM. So they would take this out, burn it, and stick it back in. Of course, it doesn't look like it has a window, so it's probably either a one-shot or it might be electrically erasable. This is interesting, these 2 work RAM chips. The numbers aren't exactly the same, but the package size is the same. So this is gonna be 128, total of 256K of RAM. So it is quite likely that the cartridge is how they loaded the data off the CD-ROM, because we didn't really find any additional RAM in there besides what the Super Nintendo already had. So this is probably where they put everything. So you would need this cartridge in order to use the CD-ROM functionality. Yeah, so this is probably gonna be your region or your lockout chip right here. This, I guess we can look up. Well, again, we see CXK5864, so that's probably gonna be an 8K RAM. So see again how we have the -12LL.
Oh yeah.
Yeah, we can look it up, but I'm guessing that's gonna be an 8K RAM. Oh, look, a data sheet. Yay, oh, thank you, Sony. It's an 8K RAM. Maybe this RAM is what is preserved by the battery. So the battery keeps the RAM. Sometimes they would do that to like save a game, save state. This is my bootleg Star Fox 2 cartridge that I made. This appears like it's only 2-sided. So here's the difference. See the battery right there? So there's the positive terminal. And on this side, you can't see it connected to anything. See that? Yeah. Because it's connected internally to an internal ground plane, or power plane in that case. Whereas on this one, it's clearly connected, so there's power and ground. So this one is just 2-sided. So what this is, kind of off topic, but you can buy a Super Nintendo game that has a Super FX chip in it, remove the ROM, and then put on your own ROM of like the unreleased Star Fox 2. And then you stick it in your Super Nintendo and it's Star Fox 2, which is unreleased. And you know what? I didn't think it was that good of a game. There's probably a reason it was unreleased. I know everyone's like, oh, it's great. It's like, not really. I really like the first Star Fox. I love Star Fox. Okay, along with that, we have a lot of 7.4 series logic, probably just doing the bank switching and whatnot. Not sure what that chip is, a Texas Instruments chip. Yeah, if you look here on this RAM, the uppermost pin on the right side, it's connected to a capacitor, so that's probably gonna be how it is powered. All right, so yeah, in this case, this RAM chip is connected to the 5 volts, and we can tell it's 5 volts because there's a capacitor on it. Here's the 5 volts here. So again, the pin on the cartridge is the same. Oh, it is connected. All right, well, this is definitely 8K of battery-backed RAM. So we have basically circuitry to address the bus signals coming from the Super Nintendo, 256K of RAM, probably to store things off the CD-ROM. The ROM, which is going to be, it wouldn't be a socketed ROM in a production, but this is obviously for prototype purposes. So they can pull that out, stick it in a programmer, stick it back in and reprogram it, and then 8K of battery-backed RAM. So that's probably like your settings. I thought it would be interesting to compare this SFX 100 combination Super Nintendo CD-ROM system to other CD-ROM systems of its era. Specifically, the PC Engine CD, which was a CD add-on for the PC Engine gaming console, or the TurboGrafx 16 here in America, as well as the Sega CD, which was the CD add-on for the Sega Genesis. Okay, so let's start with the PC Engine CD. Now that wasn't technically an 8-bit processor, but it had 16-bit graphics, but it ran at 7 megahertz, which is a lot faster than the Super Nintendo. It was a single-speed CD-ROM drive, which is kind of meh. Only 8K work RAM, 64K video RAM, but then when you put the CD onto it, you gained 64 more K work RAM and 64K of audio RAM to hold samples. So that system, the PC Engine CD, you were looking at about 200K of RAM. The Sega CD, which was probably the one most people have seen in the past, which is also the top-selling console preffer of all time, well, unless you count the Kinect. Anyway, the Sega CD, now that, the Genesis itself had a 7.61 megahertz processor, which was internally 32-bit with a 16-bit bus. There was a coprocessor of 4 megahertz Z80, which was used for sound, and the bus was 16 bits, which is good. Now, the Sega CD unit itself, besides the Sega Genesis, had a coprocessor that had a 12.5 megahertz Motorola 68000, so basically doubled the processing. There was also an add-on GPU for graphics, an add-on ASIC for sound, and a single-speed CD-ROM drive. So the Sega CD was almost like a whole nother system that would combine with the Sega Genesis. It also had a lot of RAM. It had 512K of work RAM, which is actually quite a bit for the day, 256K of video RAM, 64K audio RAM, 16K CD cache, basically as it loaded data from the disk, and then 8K of backup RAM for saving games, giving the Sega CD with the Genesis a total of 992K of RAM. So that brings us to the Super Nintendo with the CD add-on or the combo unit SFX 100. They would have been the same thing, either if you bought the add-on and combined them or bought the combined unit that we've experimented with on the show. So it has the same CPU and GPU as the Super Nintendo. It's basically a Super Nintendo with a CD-ROM add-on. So you're talking a 3.58 megahertz CPU, which was kind of slow, and it's made worse by the fact that it's an 8-bit data bus, not a 16-bit data bus, so it actually takes it longer to do the same things. The coprocessor, the audio processor on the Super Nintendo is a lot better than the Sega Genesis though. It's basically a sample player, so if you remember the Super Nintendo had kind of a distinct music, it almost sounded like samples, it sounded kind of more echoey, that's because it was. You would play like one key of a keyboard, record that as a sample, put it in RAM, and then play it back at different pitches to create basically what we would consider now a VST or a synthesized, well, not even synthesized, a sampled audio track. So if you heard piano in like Super Castlevania 4, that was an actual piano sample, like one note pitched to create different notes. So in that aspect, the Super Nintendo was a lot better than the Sega Genesis. The Super Nintendo also was better than the Genesis when it came to graphics. So let's see here. So we've got that, basically a slower processor, pretty good audio chip on the Super Nintendo. Super Nintendo had 128K of work RAM, which is double what the Genesis had, 64K of video RAM, same as the Genesis, and 64K of audio samples, which is 8 times more than the Genesis. If you think back, the speech and some of the PCM sounds in the Genesis actually didn't sound that great. In fact, they almost sounded worse than the Nintendo. And that's because the video and audio on the Super Nintendo were a lot better. Just unfortunately, it had a slow processor. Now, the Sony PlayStation add-on for the Super Nintendo did not have a coprocessor or an audio coprocessor of any kind, which means it wouldn't have added anything to the graphical capabilities. It did have more RAM though. So the cartridge that we had to plug in to load the CD, that has 256K of work RAM, so that triples the amount of work RAM in the system. And then the system itself had 32K of cache, basically for loading things off the CD-ROM, which is good. If you compare that to the Sega CD, it's double what the Sega CD had, but remember, we're talking about half the bandwidth because we have an 8-bit bus on the Super Nintendo, which means it would probably cache more because it took it longer to dump it back to RAM. And backup RAM for saving games, same as the Sega CD, 8K. So the total amount of RAM in a combined Super Nintendo CD-ROM system was 552K. That's nearly half of what was in the Sega CD. So even if this system had come to fruition, it probably would have had graphic capabilities the same as the Super Nintendo. I mean, the chips are the same. It's a Super Nintendo with a Sega CD add-on. And it has a double speed drive, which is an improvement over the Sega CD and the PC Engine. However, that 8-bit bus would probably cause you some problems. So load times probably wouldn't have been any better than the Sega CD, and if you remember the Sega CD, the load times were not that great. So aside from corporate politics, it's quite possible that one of the reasons this didn't come to market is because it probably wouldn't have been any better than the Sega CD and possibly even a little worse. Well, that's all the time we have for today. We did learn a lot about the Sony Nintendo PlayStation prototype.
So do you think you have enough information to fix it now and get it working?
Yeah, I think so. I didn't see anything catastrophically wrong inside of it. There were some bodge wires that were kind of shoddily attached, but we can always just repair those.
Cool.
So yeah, stay tuned. In the next episode, we're going to do our best to get that thing working again. We'll see you then. I think the Toy Story movies are completely overrated. Flame me below.
I brought my Spider-Man fishing rod, guys.
We have a couple special guests coming that have a really unique piece of something. Totally forgot what I was gonna say.
I lost my mama to a scrap and a clown.
You know, you don't get divorced and hang pictures of your ex-wife around your house. Some people might. So anyway, The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.